This is part 2 of the tutorial on DatabaseLink with Wolfram Language, and this part covers data types, how to query the database. We'll see some descriptive commands, few data commands, and how data types map, and a few examples on creating procedures and functions. Now, this chart shows you how the different Mathematica types map onto SQL types. It's very easy to understand. All the string types are character, varchar, long varchar, or real or double float and real. And same for true, it's a bit, false is a bit, null is null. And then there are three special types, which is SQL binary, which is for binary data, and SQL datetime, which is for date, time, and timestamp data. And there's the SQL expression, which is for storing Mathematica expressions in the database. And we will see these three special types in the next slides. Now, before that, let's go through how to evaluate queries from within Wolfram language. And to do that, we know that there are two ways in which you can do it. One is the Wolfram language style queries and SQL style queries. In Wolfram language style queries, you use the Wolfram language built-in functions and provide arguments such as table names and SQL columns and any conditionals that you want to provide. So let's try an example here. Now open SQL connection. Publisher will open a connection to a built-in database which is called Publisher, and SQL tables will list all the tables that are within that database. Now we want to select everything that is in the sales details table. We'll do a SQL select on it. And if you want to select certain columns with a condition which is quantity shipped is greater than 20, we'll give a condition like this with the SQL column quantity shipped greater than 20. Now we will evaluate the same commands in SQL style, which is by providing just the raw SQL command to a function called as SQL execute. Now this SQL execute is like a super function that can take any SQL command that you would rather run in your SQL terminal or standalone database that you can also run through SQL execute. So same sales details table, and you select everything from it. And here you provide a condition where quantity shipped is greater than 20. So notice that you're providing 20 as a parameter here. Now this is equivalent to giving the SQL select command. Some of the descriptive commands that are built into DatabaseLink are SQL table names, SQL tables, and SQL table information. So these set of commands give you all the information about the table itself. For example, here, if you do SQL table names on the publisher table, a publisher database, it will show you all the different tables that are in that database. And SQL tables give you a little more descriptive version of the same. Let's say if you want to know if there are any views in the database, and you evaluate that with table type goes to view. Since there are none here, it returns an empty list. And if you want to know SQL table information in a lot more detail, then you can evaluate SQL table information and then show column heading set to true. So if this will also give you the name of the columns and then its values. Similarly, you can know more about the columns and its related information by using SQL column names. By providing this table name here, you can know what are the different columns within that table. So you just get the column name, you eliminate this table name, and so for that you just need to do all comma 2. And a little more information on what each column name is, what their data type is, what the size is. To know that, just use column SQL column information. So, and similarly SQL columns here. So this is just a list form of the above expression. There's nothing different here. It's just that it's wrapped around this / table form will give you a nice table form, easy to view. And you have this SQL show column headings here, which you don't have here. So it doesn't show you the column name separately. Now, data commands are related to the way you query data from a database. So let me just make sure that I have a connection open here, and I'm gonna just see. Okay, so I have a connection open to demo database again, and we will list what are the tables here. So there's one table called sample table 1, and let's say we want to see what are the different columns in that table. Okay, so we have 3 columns, and this will give some information on the connection, which we saw even before also. So let's start with a simple example of creating a table within the demo database called as test table. So let's do that. So I'm gonna and we know that there is no test table, but if a table already exists, you can drop it before creating. Otherwise, it's going to show you an error saying that the table already exists. So we know that the test table is not there in demo database. So let's not evaluate this command. So let's just go to SQL create table, and that will create the test table. And now if we see the list of tables, it should show the new table that we created. Now we'll create some data and insert it in the database. So here, this is the list of data. So SQL test table has 2 columns. One is an integer and one is varchar. So we provide a list of an integer and a varchar, and we do SQL insert with the connection object, the table name, the column to which we want to insert the data, and the data itself. Now you can also insert more than one column in one SQL insert statement, and for every successful insert it will return a 1. So if it returns a 1, it means that the insertion was successful. Now if you select from test table, you should see that the columns that you inserted are there. Now similarly, you can just create a whole bunch of rows to be inserted, and just quickly do that and then put it all in one go. Now if you want to select from the table, just do a SQL select. If you want to update any values within the table, you can use SQL update, and with the data that you want to be updated, and for all the columns that are greater than 5. So 5 of the rows got updated, so this will return you the number of rows that changed. And if you look at the table data again, you can see that everything which is above 5 has been changed. Now if you want to delete, so these are repeated rows, let's say we want to delete all the rows that are greater than 5, just do a SQL delete, and again check with SQL select that they are deleted. If you want to drop a table, you can always do a SQL drop table, and that will delete the table from the database. Now in the first slide, I showed you the data type mappings and told that there are 3 special types that you should be knowing about. So let's go through those types. The first one is SQL binary. This is for storing any binary data. So let's say we have a plot in Mathematica, and if we want to export it to a GIF and convert it to a binary data. So we are doing a 2-character code of the exported string and then just wrapping it with a head SQL binary. Now we already have a connection open to demo database, so we are not going to evaluate this OpenSQL connection again. Let's create a table called bin data table that will contain with this data. So first create the table and then insert this binary data. So once it is inserted, you can read it back just like any other database. You can just do SQL select on it, and it's nothing different here. So once you get back the data, you have to convert it back to a form which you can recognize, like your plot again. So you do a from character code and then do an import string on it, so you get back your plot. So in this way you can just store this plot data in the database using SQL binary. Another data type is SQL datetime. Now this is also used for storing date and time information. Here's an example. So in Mathematica, date evaluates to that list, and let's say we create a table called as datetime info, and we insert some data into it. Now this data is, you can see that I'm just wrapping this date with SQL datetime to let SQL know that we are sending datetime data. And then you can also use the built-in date object function in Wolfram language to insert the data. So this doesn't need the SQL datetime wrapper. This is that is something added recently in DatabaseLink package. So this doesn't need the SQL datetime. And when you select it, it comes back with this SQL datetime wrapper. So even if you insert as a date object, it's going to come back as a SQL datetime object. And then just drop the table. Another type is SQL expression. So SQL expression is something which you can use to store Mathematica expressions as it is in the database. So let's say we have this integrate expression and we create a table with a column that will store this expression, and just insert that, and when you select it, it just comes back with SQL expression. You can just drop the table. An important point to note here would be to see in the documentation how this SQL expression is interpreted after it comes back to the language. The function that does it is called identity. So for example, here you have the SQL select expression, and then you get back this expression sign of x square. Once you wrap an identity over it, it just grabs this sign of x square and replaces it with that expression in this plot function here. So that's how you can just extract the expression out of this SQL expression. Okay, so DatabaseLink does not have any special functions or built-in functions to create procedures and functions. But there is this super function that is the SQL execute that can take any raw SQL command. And the same we can use for creating a procedure. So I'm going to show an example here. So we have a connection open to my MySQL database. Okay, let's try again. So I need to log in as root. Okay. And I'm gonna actually drop this table which already exists and recreate it to just show you that how it gets created with SQL execute. So the create table command that is in SQL, that the same command you can use it here with the same syntax and everything that you would put in a SQL, and just wrap it with a SQL execute command and give the connection object here, which is my SQL connection, and evaluate that. So I get a 0, which means the table was created successfully. Now this table is a weather data table and has columns city name, city ID, city name, start date, end date, average temperature, wind speed, and pressure. And we will create some dummy data to be inserted into this one. And let's say we have that now. And then just to create the procedure, it's same as how you create a table here. So instead of the create table command, you were just giving the create procedure command. So I've stored this in a separate string called as proc insert, and I'll just wrap a SQL execute around it, proc insert. And now the procedure is created. So I get a 0 back, which means it was created successfully. Now if I want to run the procedure, I can just use call and then the procedure name and evaluate, and you get the data back here in the notebook. Similarly, you can create functions, and to do that you just use the regular SQL command create function with your SQL syntax. And here's an example wherein I have this function called as get warning, and this works off the weather data table, and there is a condition here which issues a warning if the temperature is more than 30. There's a heat warning, and if it is not more than 30, there's no warning issued. So when we run this particular function, giving it a city name, and so we will know for that day if there was a warning issued or not. So let's just run this example and just use SQL's execute again with your connection object and the function string. Evaluate, you get a 0. The function was created successfully. And to just call the function, you can just use a select, or just get the get warning function, put an argument from weather data and evaluate that, and then we know that there is no warning issued. So whatever is the function and whatever is the data that you get back in the Wolfram language and within your notebook, and then it's just a list of data like any other data that you can use further in your computation or for any other importing or exporting or modeling, anything. So that's the tutorial on getting and running the database commands. And there's a bunch of resources available. Let me show you this one by one. This is the one on data types. So we saw a data type mapping thing, which is the same here. And each of these data types has a separate documentation page, which you can go to and just go through the various examples that are there. And the querying the database has its own set of functions. So selecting, updating, inserting, deleting, and all the different functions that you can use from within the language are here. Now there is a separate section on the SQL binary, SQL datetime, and SQL expression. They have their separate detailed documentation, which you are seeing here right now. And last one is SQL execute. And SQL execute supports a parameter form also, and that's also demonstrated in this documentation. Let me just quickly show you the user guide here. So this is the DatabaseLink user guide, and there's a lot more in it than the topics that we covered here. So in the descriptive commands and data commands specifically, you can see how to create schemas and catalogs, and a little more detailed on every topic, and saving queries and how to use the connection tool, how to use the new connection wizard. So this is pretty much half the way into the DatabaseLink user guide. And the next section is part 3 of this tutorial, which deals with the slightly more advanced topics of batch insertion and how to use DatabaseLink with cloud, and how to deal with database link when you have large sets of data.